Hello everybody. This is Professor Wes, and welcome to the segment on branching, otherwise known as conditional statements or if statements. And the first thing you need to know is if statements are extremely important in the computer programming world. The reason is because until now, every program that we've written starts at the top and just goes line by line until it gets to the bottom. With if statements, we finally have the chance to control some of that and have it skip certain lines if the condition isn't met. So sometimes this line of code will run and sometimes it might not. And that's completely different than what we've been doing up to this point, where every line runs and it always ends up the exact same. So why do they call it branching? In order to understand branching, we have to look at a flowchart. This is our typical decision statement, as we've discussed before in flowcharting. And until now, we've had it set up so if the condition here occurs, then we move to the true statement, and if the condition is false, then we move to the false statement. That's very close to what we're talking about with branching. But with branching, we can actually have it a little different. This is not how you represent it in a flowchart. I'm just doing this to show you a little bit better what's going on. So in this case, we would have a condition that would come down to here, and then from here we could branch out any of these other directions depending on what's going on. So this probably should actually have a circle in there also. But the point is, we don't necessarily have to have one thing come off if it's true and one thing come off if it's false, because now we can use if statements, if else statements, elif statements, which we'll get to in just a minute, and so forth, and we can have more than one possible outcome. So just hang on, we'll get there. In the book here, in the Ascii book, if you're one of my students, I'm sure you're following along, you'll see that right here is an example. We have an if statement and then an expression with a colon at the end, and then whatever you want to happen. Now we can have one line of code here, 5 lines, 10 lines, 100 lines, whatever, it doesn't matter. And until we get to the else statement, which is what happens if that doesn't happen. So if this expression is true, then the code beneath it occurs. If it's false, then everything occurs in the else statement. If you take a look down here at this actual code, the example here, they ask you to input a number. They're calling it age, so enter somebody's age. And if it's less than 25, these two lines of code will execute. So it says price equals price younger, and which the price younger is 4,800. And then it has it print executed first branch, because this is the first branch of our if statements. Otherwise, the else statement executes, and that would be these two lines. Now, one thing you notice here, these two lines under this if statement are indented, and they're indented exactly the same. Typically, we use 4 spaces. Let me see. They don't have actual spaces there, so I can't really see, but typically, we use 4 spaces to indent. The next one, you indent the exact same amount. It doesn't matter how many. If you indented it 5 spaces, then you indent this one 5 spaces. Do not use tabs for this, and I'll explain why in a moment. As long as you indent the same amount, if in Python, then the code realizes that these are part of the if statement. So if this one had been indented less, if it was indented this far, then Python, while it's running your program, would have thought this was part of the if statement and this was not. So this can be a little confusing. You have to make sure these are the same. So why did I tell you to use spaces and not tabs? Because different programs interpret tabs differently. Some interpret tabs as 3 spaces, some interpret it as 4 spaces, some might even think it's 5 spaces. And it's not always the same. So if you write it in this program, it may think it's 3, and then when you run it in a different program, it may think it's 4, and it may not exactly line up the way you think it should. So just don't use tabs. In fact, that's a good idea in programming to never use tabs. Just don't even do it. So, as long as these line up, then it knows that when it comes to this next else statement, since it's still part of this if, it runs this else as the opposite of the condition. If this line, as I said, had been put here instead, then the program would have thought the if statement was ended, which means that it wouldn't have known what to do with the else statement, because as far as it's concerned, there's no if statement on the immediate preceding line. So that would have caused another error, and you would have been looking at it saying, why is it saying there's no if statement when there's clearly one here? Well, it would have not recognized that this was part of that if statement. So the next thing you need to know, let's move down a little bit here, is, let's see, they're still talking about else statements here. And here's some examples of how to use them. And let's see, translating description into the branches. Writing your own if statements, you can do all this. Let's see. And if without an else, here's an example of that. This is what I was talking about. Here's the if statement. If absolute value is less than 0, colon. Make sure you have that colon there. And then this line is tabbed over 4 spaces. So absolute value equals blah, blah. Well, here's a print statement, but it's not tabbed over. So the computer reads this and says, this one was tabbed over under the if statement, so it's part of the if statement. This one is not, so it's not part of the if statement. So if I wanted this to only occur if this is true, I would have needed to move it up a line and tab over so that it's the same as the absolute value. As it stands right now, if I put an else statement right here, the computer would not understand why there's an else statement there when this is not part of an if statement, and there's no if statement before it. So that's exactly what I was explaining up above. And let's see, move on down, go to the next section, and now we're going to get into something called relational operators. Sometimes they're called equality operators. The reason is because they're testing to see if they're equal, or checking the equality of the two, I should say. We're checking their relationship. In this case, this is called the less than sign. You've probably seen this in math class a whole bunch of times. And this literally would read A less than B. So if I put an if statement there and said if A is less than B, then the computer would check. And let's say A had the value of 10 and B had the value of 5. It would ask, is 10 less than 5? No, it's not, so it's false. If it was the other way around, if A was 5 and B was 10, then it would read and it would ask, is 5 less than 10? The answer would be yes, so the stuff immediately under the if statement would run. It's less than because it points, it makes this little alligator symbol, it points to the left. If it points the other way, this one's called greater than. It's very easy to mix these two up. But if you read it out loud, A is less than B and A is greater than B, it helps. In these next two lines, we also added an equal sign. So now it's saying if A is less than or equal to B. Now, in the case of I was using a minute ago, I used 5 and 10. What if they were 10 and 10? If A was 10 and B was 10, then this question would ask, is A less than B? Is 10 less than 10? No, it is not. A is not less than B if they're both 10. But come down to this one, is 10 less than or equal to 10? Yes, it is. So if you need it to have a possibility to be equal, then you have to add this equal sign. Come down just a little bit further, A equals B. Now, why do we have to have two equal signs here? That seems silly, right? The reason is because whenever we assign values to our variables, so far we've said something like x equals 5. An equal sign assigns value. It assigns the value from whatever's on the right to whatever's on the left. X equals 5 assigns 5 to x. So when we're checking using the if statements, we have to use equal. That asks, are they the same, rather than assigning it. If you only put one equal sign here, then it's going to assign whatever B is to the value of A. So if A was 5 and B was 10, if you only use one equal sign, B is now going to be assigned to A, which means A is going to be 10 and B is going to be 10. And that's not what you're wanting to do. Last but not least, this is an exclamation point. We call it the not sign. So if you literally read this line, it says A is not equal to B, which means that if they're both 10, if A is 10 and B is 10, then this would ask, is A not equal to B? That would be false. Every other number in the world, though, B could be 10, 0.5, B could be 20, B could be 50, B could be 1. It doesn't matter. As long as they're not exactly the same, it would be true. Let's see. So, what you've seen up to this point, these are all called Boolean expressions. As we've seen, a Boolean is either true or false. There's no other option. Every one of these statements that I'm pointing to here that are relational operators or equality operators, every one of them is either going to evaluate to true or false. There's no chance that it's ever going to look at this and say, is A greater than or equal to B, and have another option besides true or false. So it's always going to either be true or false. And because there's only the two choices, it's called a Boolean value. One thing I really like about this book is they have these things that they show called common errors. And here's one that really trips people up sometimes. A common error would be to have equal, greater than. You cannot have that. Notice here we have greater than or equal to. You cannot have equal to or greater than. It has to have the greater than or less than symbol first and the equal symbol second. You cannot have a not less than or a not greater than. If you're going to do a not less than, then just do a greater than or equal. You know, you have to do it the right way. And in Python, you cannot use this symbol here, which is a less than and a greater than symbol together. In other languages, you can, but in Python, you cannot use this. So, and lastly, it's talking here about how I was mentioning earlier, how you have to have the two equal signs if it's a comparison and not just one equal sign. Okay, if you scroll down just a little further, the next thing we're going to talk about is operator chaining, which simply means, think of links in a chain, having more than one. So, in some instances, you may want to say if A is less than B and B is less than C. Now, let me show you using this diagram here. In some cases, you may want to say something like if A is less than B and B is less than C. We can shorten it in Python and simply say A is less than B, which is less than C. So, let me explain what's going to happen. In this example here, the computer would check this and say A is less than B, and if it's true, it would check this one and say B is less than C. If that's true also, then the whole thing would evaluate as true. This is just a shortcut way of writing it. The same exact concept is going on here as what's going on here. So the computer would check, starting from the left, it would check to see is A less than B. If that's true, then it would continue on to say now is B less than C. If A was less than B, then it would stop right there and say, oh, it's false. Because both have to be true when you do it this way in order for the expression to evaluate as true. If either part, if B is not less than C, or if A is not less than B, then this whole statement would be false. So that's just a little bit simpler way to write it. But if that confuses you, you can write it the other way. So, and here's another thing that they want to mention, and that's when you try to compare, in this case, numbers, the number 1 to the letter ABC. You cannot compare two different things. You've heard the expression, it's like trying to compare apples to oranges. It's the same concept going on here. You can't compare numbers to letters. It's just not going to happen. And there's a very good reason why. because when you try to compare something to a character or a string, what happens is the computer converts that string into ASCII code. So, for example, the letter A has an ASCII value, the letter B has an ASCII value, and the letter C has an ASCII value. The capital letter A has a different ASCII value. B and C also have different ASCII values. So these would evaluate as different, even though they both say ABC. So let me pull up an ASCII chart and explain the difference real quick. If you take a look here, you'll see that the lowercase a, this column here has the characters. This column has the HTML values. This column has the octal values, or whatever they call them. This is the hexadecimal value and the decimal value. So if I'm changing it into hexadecimals, for example, the lowercase a would have a hexadecimal value of 61. The uppercase a would have a hexadecimal value of 41. So the uppercase a is not equal to the lowercase a. So when I'm comparing, if I try to compare it and one's uppercase and one's lowercase, it's going to be false. And this comes in very handy later when you're trying to compare things, because sometimes if you don't capitalize something, or if you do capitalize it, it's going to make a big difference. So in this case here, they're actually trying to compare the word Friday. And if you're wanting to compare something to the word Friday, then they have a capital F. You would have to make sure when you compared it that you had a capital F and a lowercase Friday, or else it wouldn't work. And anyway, let's move down just a little bit here. We have these relational operators in the if-else expressions. Check this out. This says num items is 3. If num items equals 3, which it obviously does because we just said it, then num items equals num items plus 1. And notice that they've tabbed over underneath the if statement. And actually they have not tabbed over, they've spaced over. Like I said, don't ever use tabs. I say tab over, but if I ever say tab over, then use spaces. And you can see here, when I highlight it, there is 1, 2, 3, 4 spaces. So make sure, even if I say tab, make sure you know that I'm talking about spaces. And here's you a challenge activity to complete. Some basic if-else statements. And we'll move on to 4.3. This is using multiple if-else statements. Now, this is very important. Notice that here we introduce a new command called ELIF, elif. It's short for else if. In some programming languages, we actually used to use the words else if, but I guess they thought that was too difficult to type. So they decided to change it. So check out this example here. We're going to input the age, and then it's going to say if age is less than or equal to 15. And is it? If so, then you're too young for car insurance. Your price is 0, because now we're trying to calculate the price of somebody's car insurance. Then it says, now if this is true, these two lines would run. If it's not true, then it's going to come down here. And before we had the else statement, which is moved down further towards the bottom. The else statement automatically ran if the if statement was false. But the elif statement is actually another if statement. So now it's saying, else, if age is less than 24, then your price is some other value. So let's say I would have entered 22. Well, this one would have been false. It would have come down here and tested here, and it would have said, yes, it is less than 24. And that's true. Then, if we tested it a little further, if it would have been false, then it would have come down to this next else if statement, or elif statement, and it would have tested to see if it's less than or equal to 39. Now here's the important thing to remember. If this one was true, if it's less than 24, then this would have ran. It would not have come to this next else if statement. Once it finds one that's true, if this one were true here, if this is 15, less than 15, then it would have ran that, and then it would skip to the end. If this one were true, it would have ran this line, but it would not have tested the next one. It would have skipped down to the end. That's why in each case here we say in this one, if the age is less than 24. Well, that actually is covering everything from 16, because here it said less than or equal to 15, through 24. So this else statement, even though it says less than or equal to 24, is actually covering ages 16 to 24. This next one would be 25 to 39, because only if this is false, which means it'd have to be larger than 24 to be false, and still less than 39. So it'd have to be 25 to 39 in order for this one to be true and run this one. If none of those occur, then the else occurs and it runs this one. Once it's finished with all that, it prints this final statement. So that's very important for you to understand. And we can move on down a little bit here. They're still just using some if and else if statements. Here's something I wanted to show you. In this case, I'm on 4.3.6. It says your number of boxes is 0, your number of apples is 9. If the number of apples is less than 10, is that true? Yes, it is, because it's 9. Then your number of boxes is 2. Now, this is a completely different if statement, which means no matter whether this if statement is true or false, this if statement is still going to run. It's still going to execute. So, if number of apples is less than 20, then whatever your num boxes is, which it's 2 because it was 9, so num boxes is now 2, and we're going to add one more. So num boxes is actually going to be 3. Let's test that and make sure. There you go. And that's because this statement, if this statement were false, if number of boxes was not less than 10, let's say it was 11, then this statement would have been false. This statement would have still tested, and it would have still ran. It would have said, okay, yes, that one's true, so it would have added 1 to 0. But because this was a 9, we went ahead and got 2 boxes to start. I apologize for that, everybody. My dog just barked. So, let's move on down a little more. I have just a couple more things to show you real quick. And let's move into 4.4. And Boolean, I already told you, it refers to either being true or false. And we have some examples here. This is a Boolean operator. And, or, and not. These are our 3 options. So what does that mean? I already explained to you in my example a while ago. Remember when I showed you this and I said you could say if A is less than B and B is less than C? That's exactly what we're talking about here. Only they actually put them in parentheses, which is what you should do also if you use them like this. So, in order for an AND statement to be true, both statements have to be true. If age is greater than 16 and age is less than 25, then the statement is true. But only if both happen. If the age is greater than 16, but your age is 26, then this second statement would be false, so the whole thing is false. With an OR statement, only one of them has to be true. If the age is greater than 16, or the days is greater than 10, if either one of those happens, you could be 14, but the days could be 11, this statement would be true. Or you could be, 17, and the days could be 5, and this statement would still be true, because either one has to be true in order for an OR statement to be true. Not just changes it. It totally flips it. So, days is greater than 10. Let's say days was 12. Then days greater than 10 is 12 greater than 10. Yes. Therefore, not flips it, and now it's false. Which is kind of a silly thing to do, because you could have just done it with a negative sign, or less than sign. But that's how they work. That's something that you have the option to do. And here's you some practice examples. Here's using some Boolean operators. And a good practice is to use the parentheses in expressions to make the intended order explicit. So what they're saying here is, even if you think that, it starts at the left and works to the right, and you think that it would evaluate properly, go ahead and put it in parentheses just to make sure. And that way, in my example here, let's say, let me change it up a little bit. Let's say or, and then maybe I'll come down here and say and C is less than D. So now my statement here would read, if A is less than B, or B is less than C, and C is less than D. Well, maybe I want this section to run first. Actually, let me go ahead and put everything in parentheses, in quotes first, or parentheses first, so that it's more like what you're seeing in the book. So right now, there's one expression, two expressions, three expressions. But if I wanted this one to test first, I could put quotes around, or parentheses around the two. So notice that this outer set now engulfs these two. Remember the order of operations. The stuff in the parentheses runs first. Well, the stuff in the inner parentheses runs before the outer parentheses. So it would actually test, is this one true? And let's say it is true, and is this one true? If it's false, then this expression inside these would be replaced by false. Which means that now it would be if this is true, or, and this one's already false. So only if this one's true would the expression evaluate to true. But on the other hand, if this one was true and this one was true, then this whole thing would evaluate to true. It wouldn't even matter what this is, because only one side has to be true in order for the whole thing to be true. So by using parentheses like that, it gives you some power over how it's evaluated and what happens as a result. And moving into the last section, we have membership operators. Well, okay, membership operators is a very interesting concept. In this case, we've created prices, and we've given it 20, 14.99, and 5. And you can see it represented here. And then it says print $14.99 in prices. So what we're basically asking it to do is to look in prices for $14.99. And it's there, so the statement is true, and will print. If it didn't find it, if it would have been $13.99, it wouldn't have been here, so it would have been false, so it wouldn't have printed it. So it's very interesting. You may have some uses for that. It's one of those things it's not as widely used as some of the other concepts that we've been covering, but it's nice to have the ability to use it if you need it. And then down here a little further, some examples of using some of these. There's on print could not find name on the roster if name was not in that roster. So in other words, it's telling it, the in tells it to look, and then the not tells it it's not in, which would be true if it did not find it. This is one of those confusing ways for them to use the not statement. In this case, here's our names in this roster. Alves, Messi, and Fabregas. I don't even know what that means. That's somebody's name, I guess. But it says if name not in that roster. So the in that roster would tell it to come up here and look. And let's say you entered Bob. So that would be false, because Bob is not one of these names that's in this roster. So the in that roster part would evaluate to false. The not, like I told you, would switch it to make it true, which means now this expression is true, so it would print could not find the name in the roster. It's another way that you can do this, but if you didn't want to use the not, you don't have to. You could have done the exact same thing by moving this print line up here and this print line down here. So if it did find it, then it would have printed, found it, and here it is, and put the couldn't find in the else statement. So a lot of people prefer to do it that way and just prefer to not use not at all, because when you get into using not, it can get confusing for some people. So Just know that that's your option. You don't have to use it, but it's there if you need it. So substrings is a really cool thing that we can do. A substring is a part of a string. So here's the string. In this case, or well, let's say get index whatever. Let's say this is my string. I could actually go in and tell it to only pull out part of it. So I could tell it to go into this and just check this part. Or I could tell it to whatever I want to do. I don't have to use the whole string, in other words. So that's used sometimes if you are looking for a specific thing. If you've ever been doing let's say you're reading a paper in a Word document and you want to search for a certain phrase, for example, or a certain word, and it goes through and it says, oh, okay, we found that word, that phrase 4 times. And you click on the first one and it goes down to page 9 and shows you. That's a substring command. It just looked for that string within the bigger string. The bigger string in that case would be the entire Word document. So, it's just another option for you to use. And anyway, that's pretty much it, you guys. The final section is on indentation, and they're going to go over more of what I was telling you. We call it a code block, but how they have the if statement and everything is spaced over the same amount to be part of that if statement. And here they give this example where they have an if statement and they have these 2 lines spaced over the same, and then they have a second if statement inside of it, and these lines are spaced. So the computer knows, because of the way you spaced it, that this if statement is inside of this one, whereas this if statement and this if statement are on the same level because this one's back even with the left. So this if statement would run, and regardless of the output, this if statement would run. Regardless of this output, this if statement would run. However, this one down here only runs if this one's true, because this one is inside of the spacing over, or the code block for this one. And you can have more. You can have another if statement here, or you can have them on spread out. That's actually very common. And that's part of how we get to branching, is by doing our if statements like this. This one would actually be a branch of this one. So anyway, they talk here about good practices and say it's a good idea to use four columns or 4 spaces when you're spacing. A common error for new programmers for Python is mixing tabs and spaces. Never mix the tabs and spaces. That's what I was telling you earlier. Oh, there you go. It actually says it right here. Some do 3 and some do 4 spaces, so it could change it up on you. So always use spaces and never tabs. And moving on down, there's some examples of indenting. And wow, I thought we were almost done, but now there's a section on conditional expressions. So let's do that real quick. Conditional expressions have the following. Basically, a conditional expression is combining your expression with your if statement. This only works when there's only one possible expression to be part of it. Let's look at this example down here. Yeah, it says it's a good practice to restrict the usage of conditional expressions to an assignment because it can be confusing to people. But let's look at one real quick. Let's see. Oh, they're actually not giving us a good one there. So let's look down here. Here's your expression. You start off with your expression that's going to happen, and then your if statement, and then your condition, and then your else can appear. So in essence, if it's true, this happens, and if it's false, this happens. And believe me, that can be really confusing to people when you have your condition after the expression. So that's why they're telling you here, use it very sparingly, but you need to know that it is an option, that you can use it this way. So I've honestly never found the need to do an expression like that, but I have updated other people's programs that used it. So this last section here is just some practice. They're just decoding common Twitter phrases like LOL and BFN and stuff. It's just a program that the whole point is to test out. You know, you enter the abbreviation and then it would test to see what it is, and you can run it. If LOL's there, then it tells you, oh, that's the abbreviation for laughing out loud. And if you want to do one of these other ones, say BFN, and run it, and then it says, oh, well, that means bye for now. So you can play around with that. You could add more if you want. You can do whatever. Just test it out. But it gives you some examples of using the elif statement some more, and comparing variables to expressions. So anyway, and then the last section is just your warm-up. So that's it, guys. Sorry this one went a little long. I tried to keep them short, but there was an awful lot to go through in this chapter. So I hope you understand branching a little better and conditional expressions. And I will see you guys in class if you're one of my students. And as always, even if you're not one of my students, feel free to leave me questions and I will answer them. And have a good day.